In this quick demonstration, I would like to show you how you could build the kickstand. The kickstand itself is actually quite a simple object, but because the way how it has to rotate, it can actually be a little bit challenging to imagine how you have to build it, but through applying some very basic knowledge about geometry, it's actually not really that difficult if you start breaking down that problem into smaller problems and then step by step go towards it. So how I start is actually creating a plane. This plane for me functions simply as a reference for my ground plane. And I'm going to move it to roughly maybe where I would like the kickstand to be located. Then I duplicate this plane, rotate it by 90 degrees, and maybe move it over a little bit. So you might ask yourself now what the reason behind this is. Uh, the main purpose is I don't want to rotate my bike, so it's kind of like in a position like with the kickstand pulled out. So I just create an artificial ground plane and then rotate that ground plane so that maybe I get kind of like a feeling for the angle my bike would be at the ground plane. And of course, something like this might be way too much. And for example, you can see now with this line here, I can check where maybe the perpendicular axis for my seat would be. So I can clearly see that this angle for the ground plane is way too much. And something like this seems to be very possible. I'm going to scale this one down a little bit more. It doesn't have to be that big. So how I'm going to build the kickstand? Well, I can simply start somewhere first with a cube. And let's scale it down. Then I go into top view. Maybe those two planes I just put to here for a moment. And then I assume that probably the kickstand where it rotates, I need to have some sort of a 45 degree, something like this. So in edit object mode, I rotate this one 45 degree like this, and then going to select those points in local space, rotate them out. First I extrude and then another extrude and move it out. Sorry, not rotate, but move it out. So something like this. Of course, that's a little bit too big, so I guess I have to adjust my thickness here a little bit. Again, that's a nice feature of working with global and local, because as you can see, I can easily adjust my geometry by scaling and moving along the respective axes, and also I can snap and then again move in local and global space orientation. So maybe something like this could do it. Let's get it down along the z-axis maybe a little bit. Okay, well, as you can see, this front part is at 45 degrees. So in case I press R and X, you see that I can rotate it now along this local axis, which is why I rotated my cube the first time by 45 degrees. So I can actually rotate this thing in local space. And then it's properly kind of like a combination of local and global orientation, I would like to maybe have this object a little bit lined up to my bike. So let's see, well, maybe that's a little bit too close. And of course the kickstand is a little bit too big right now, but at the moment I leave it at this, so it's just simpler to see. I'm trying to adjust the rotation a little bit, positioning. And maybe this part here I don't really need, so I could delete it. This part, maybe I move out a notch, fill it, and then at those 4 points, I snap my 3D cursor to, and then in object mode, spacebar, origin, reset my object center point to where my 3D cursor is. So when I type in R for rotate, X and X for local, it rotates around the axis where my 3D cursor is. And also, having this done, I can easily maybe this, I would like to go down, and maybe this way. Let's take a look at the top view. Okay, and I can maybe select those faces, duplicate them, move them local space a little bit, extrude them out a notch more, push them in, and maybe with L select all those vertices, press P to separate it, so I have two separate objects. And then I can simply click this object, RXX, maybe type in 90 plus 45 is 135 degrees. And then let's turn on our ground plane. Like in top view, we will see how far, for example, this thing sticks out to the side when we type in 135 degree. If maybe we only rotate it by 90 degrees, it will be somewhere there. Another 90 degrees is there, so that's actually way too flat. So maybe rotate XX 135. Seems to be somewhat okay. And then we could go into a side view. And because this face, the lines are parallel, I can go to normal orientation and then maybe from this view pull those points back. Actually, hold on, let's do it maybe this way, and this way will be a little bit easier. You might maybe ask yourself what I'm going to do here right now, but check this out. If I'm going to delete all those points here I don't need, I'm going to pretty much end up with 1, 2, 3, 4 points. So 1, 2, 3, 4. Fill. See that it's on the same line. So I used loop cuts actually in that situation to do that job, and then I can patch in the missing faces by selecting the correct edges. So this way, for example, I would have a kickstand that has also the correct floor orientation in case I would pull it out and then position my bike. And then of course you could go ahead and maybe, let's say, scale this one down, select this last loop cut here, scale it out maybe to make it a little bit thicker, and continue sculpting then your kickstand. And then you can think about how maybe you would like this thing to be inserted into the frame. Do you want to blend it in? And then, for example, right now this is still very rough, but I would need to find a way that stylistically or design-wise it gets the same visual form language than like the bike, so it doesn't look like a foreign object, but rather flows into the bike, so it's consistent. And you see, for example, my caps for my axis, they have the hex nut center part, and I got this idea from my main axis where the center part is pushed in so that they look a little bit similar. It's because very often really good design visually is just nothing else than being consistent inside your form language.